I wanted to create something like that. So back in Germany, I bought all the equipment. I was doing photography gigs, weddings for the African community as well as the German community. And I moved back to Ghana to start this business. Unfortunately, it did not work out. I was devastated. I don't know how to put it, but as I'm speaking to you, the equipment are still packed in my house. The interesting thing is that I did my master's in communication engineering, and I specialize in communication engineering and navigation systems. And there was a time that one of my lecturers was a visiting lecturer from the European Space Center, and he came to lecture us about UAVs, which we call Unmanned Aerial Vehicle. And when I was returning from Germany, I bought one of the small little drones, which we call like DJI, the DJI drones. And with that, I created some photography company with that. We were primarily doing photography for events and stuff like that. But I mean, at the back of my mind, I have had an extensive engineering education with drones. So the following year, we decided to set out some cutting edge technologies in terms of how we can use drones for good, in terms of collecting data, processing data, analyzing data for specific industries, and how we could also support them. We were able to target the mining sector, the oil and gas, the surveying and mapping industry, as well as the environmental sectors. As we go along, we would take a very deep dive into what we did primarily, or what these drones were used for within this industry. In the year 2019 was a big milestone for us. We were contacted by the Ghana Armed Forces to train the Ghana Armed Forces on the use of drones. And after the training, the Armed Forces saw the potential our company has, and we were invited to the table to jointly partner the Ghana Armed Forces with one of their training arms, which is a signal training school, to set up the Center for UAV Research and Educational Unit to support the Ghana Armed Forces with drone education and research, targeting both the military and the civil space. It has been a very interesting journey. A lot of products have been developed. And this year, even in the midst of the virus, we've still kept our goal. We've been able to achieve this milestone where we have fully developed a full-blown unmanned aerial systems research lab, where with the knowledge gained from our education and research, we are now going to start building drones locally, as well as repair and provide services to the sub-region, as well as the other clients that we have. Please, if you can hear me, let me hear hi. If you cannot hear me, let me hear hi. You can give me a thumbs up.
Hi, we can hear you.
We hear you.
Okay, thank you. Thank you so much. Thank you for the acknowledgement. Now I know I'm speaking to people. And in case I'm speaking very fast, kindly draw my attention. And yeah. So today we're going to learn about what are UAVs. We're also going to learn about who regulates UAVs within the country and what are UAVs used for. And we'll be also looking at some career paths which are coming up, and it is very unconventional within the educational space. And I'll be introducing you to our team. It's a very small team, you can imagine, but a very powerful one. So what are UAVs? Primarily, I will look at it as any flying machine where the physical pilot is not situated within the aircraft, but mostly they are on the ground with some kind of remote control sending instructions to the aircraft. So when you take the word man and unmanned, the difference here is that with unmanned, the physical pilot is on the ground, and with man, the physical pilot is situated within the aircraft and controlling the aircraft. We will go by GCCA's definition, which GCCA here means civil aviation. So that is what we're going to stick with. The traditional UAV, as we know within the civil space, comes in primarily two configurations, which is the multi-copter or the multi-rotor system and the fixed wing. So I'm sure a lot of you have seen a lot of this one being used for weddings within the country. Unfortunately, I'm not sure most of you have seen this type, and I'll be very interested in knowing if you've seen any of this. Come again. Hello. Okay, so a lot of people have seen it in movies. Yeah, yeah. It's very nice. You've seen it in movies. I'll be showing a couple of YouTube videos, some from our website, some of our works we've done. Only in movies. Oh, okay. Then maybe when when the coronavirus is down, you guys could come over to our lab to come and have a look at them in real life. We have all these drones that I'm talking about in our lab. We have these drones in our lab. So if you also go to our social media handles, you can also see some of these pictures in there. Just type SokoAerial Robotics. Robotics, and you will find out a lot there. So let's continue. I'm happy you guys have seen them in books. So we have all these drones that I'm talking about. We have them in our lab. Our lab is currently in demo camp. Now we're going to look at the two main categories of drones. So we have what we call the model aircraft, and then we have what we call the drones. The main distinction comes in terms of its operation as well as its functionality and composition. So great, Lawrence. We'll be happy to have you guys. Probably maybe James have to organize a field trip, and then we will prepare and we will give you a day session where we introduce you to all these drones. But I also have here on my decks, I'll be also introducing you to some hardware as the training goes on. So with respect to the difference between what is a drone and what is a model aircraft, with respect to operations, drones primarily have a lot of intelligence. Intelligence in the sense that they can perform specific functions on their own without an input, or let's say without the pilot directly asking the drone to do that. And this particular system, which we call autonomous control, is given by a particular board. So I will turn on my camera and see if you guys can see this board. So once I'm done with the it looks like because I've shared my screen, I can't turn on my camera. So I don't know. Maybe we'll see if I can do that.
I think if you want to do it, you just stop screen sharing and try to turn on the camera. Once you are done, then maybe you can just start screen sharing again.
Okay, so let me stop the screen sharing and let me show the camera, the device. So this is a board I have in my hand here. It's a programmable board, which I do a lot of programming. That's my area of specialization, especially with the firmware and the mission planner. So this board is called a Pixhawk. When you come to the facility, you see a lot of these boards, and this is the board that provides the intelligence for the drone. Yes, so I will go back to my presentation and you get to understand what this board does. It gives it full autonomous systems where we don't need to put a physical human pilot in there. This board does all the work. Yes, Franklin. Yes, we did the fumigation exercise with some other partnered company in Accra. I think we did the whole of Ghana. Yes, we did that. We did that for the COVID-19. The types of drones that we use were spraying drones. Yes. Now, when it comes to operations, drones have this intelligence because of this board I just showed you. Model aircraft do not have this intelligence. And when you look at this functionality, these boards gives these drones special applications, which we find in the military as well as civil space. We're going to look at that. Model aircraft are primarily flying for fun. Model aircrafts are primarily flying for fun. Somebody said it's Blair, please. Is it okay now? Is the screen okay now? Kindly let me know. With respect to autonomous systems, we have two types of autonomous systems. And we have what we call a semi-autonomous control, and then we have fully autonomous control. Now, model aircraft belongs to semi-autonomous controls in the sense that we are able to control the altitude of the multi-aircraft or the aircraft in terms of holding its position. So what this means is that if we let go of the controller, the aircraft will come and fall down. So you constantly keep pushing your throttle so that the aircraft will keep flying. And when we talk about fully autonomous control, we are talking about writing a few lines of scripts or writing a small piece of program, uploading it to the drone, and then telling the drone to fly some kind of a course or fly an area. So for example, when you look at the COVID-19 exercise, when we were fumigating the markets, all we needed to do was to map the market, tell the drone to fly the market and spray the market autonomously. Tight spaces, we fly manually where we use the semi-autonomous systems. So semi-autonomous control as well as fully autonomous controls, both are on the drones. But with the model aircraft, you don't have both. You only have the semi-autonomous control. When it comes to classification of UAVs, we have primarily three classes. Now we have four. Our research facility is working on the fourth one in collaboration with other universities, but we will stick to the traditional classes. The first is what we call the fixed wing, the fixed wing class. And the fixed wing, For example, we also have a similar aircraft in our office which can fly for a very long hour. So it flies for 2 hours, 30 minutes, and it can fly for about 120 kilometers. The one big disadvantage is that it requires a runway or some kind of a launcher to launch it, as well as in terms of landing. I will show you a quick video of our fixed wing system. We flying it in our test field in Bondasi, where the military was undergoing a surveillance exercise to fly these drones. So I will stop sharing this particular screen, and then I will share that video. Yes, you're saying how is this a disadvantage? Especially, for example, if you have an urban environment where, let's say, you want to use a fixed wing drone, you need maybe 100 by 100 space to fly, or let's say take off and land. Unfortunately, in urban environments like Accra, having 100 by 100 space is not that common. I mean, you can look around. You don't have so much football pitches to even take off. And you also have quite a lot of obstructions within the atmosphere for less than, let's say, 30 meters. So it is good if you have a very open space to take off and land. Yeah, a runway, 100 by 100 meter runway. And it depends. For example, our fixed wing drone does not need a runway. It uses a hand launch system, which means that I hold it and then I toss it once the speed reach the maximum throttle. So let me just show you how we launch our fixed wing systems. So I'm going to share my screen right now. So no, with the launcher, you don't need so much space. But then if it's a hand launch system, you don't need so much space for the takeoff. But you need more space for the landing. So that's where the challenge is. And yes, for the takeoff, you don't need so much space. But for the landing, you need a huge space to take off. So I will quickly share a screen for you to see what I'm talking about. Please, can you see the screen? Yes, Augustine, thank you. So I'm going to show you so what you see there is our fixed wing. And the laptop is our mission planner, where we are able to plan the mission from the ground, upload it to the drone, and the drone flies. Okay, thank you. I think you've seen what I'm talking about. Let me show you another product from one of our friends. It's called a Pd1 drone. And you would look at how this particular drone launches. It's made by the Ukrainian military, and we are in the process of procuring for one. So look at this particular system and then look at how
Pd1 fixed-wing
it
UAV
launches.
by Spec Systems is a multi-purpose, fully composite modular drone that can be used for different missions and applications. It can be easily assembled even by one person without any tools, which ensures easy flight preparations even during cold weather, rain, or snow. For this video, we installed 8.5 kilograms of weight that simulates payload. Payload hatch could be also quickly secured or opened without any tools for easy access to payload compartment. Pd1 has a wingspan of 4 meters. Optionally, we can install smaller 3.2-meter wings. V-tail and wings are equipped with 4 servos each for maximum reliability. Pd1 comes with quiet 4-stroke engine with electric starter generator. Engine could be started remotely and also has automatic restart safe feature in case of failure. Automatic runway takeoff and landing makes it easier for the operator to control the whole process during these complicated procedures. Navigation lights come as standard equipment on Pd1. Pd1's
Yes, so that is the Pd1. Nigeria also has one of the powerful drones also within the sub-region. They have the CH-3 Chinese drone. They are currently using it to fight Boko Haram. So I will show you a video of this drone being used by the Nigerian Army.
Supposed to go out there to maintain airplanes, to fly airplanes, to undertake missions.
So that is their control room where they have their ground station, and that is their drone. This is a Chinese manufacturer.
Go and fight terrorists some 200 to 250 kilometers away from Yola. So several miles away from the battlefield. Guiding unmanned aerial vehicle.
Okay. So I'll get back to my presentation. So let me continue. Hello, please, can everyone hear me?
We can, but unfortunately, it wasn't able to stream well. But maybe we can get the link to have a look at. It's okay. We saw, but just that we couldn't see the streaming consistently. But it's all good.
Oh, I'm sorry. So I would maybe if you have a group, maybe you can add me, and then I can send you all these links to these platforms.
No problem. No problem.
Yeah. So let's continue. Where am I? The next type of drone to look at is a single rotor drone or single rotor helicopter. These helicopters or these type of drones, that's what we call vertical takeoff and landing. You need very little space for it, and it can lift heavy payloads. So when you look at the agricultural space, we tend to shift more towards helicopter for farm spraying, and that is one big advantage. The other disadvantage is that it's very hard to pilot because it has a lot of moving parts and it's very complex in terms of maintenance. So as of now, our facility does not have one of these. We are in the process of procuring one for our training school. So we have a fixed wing, but we don't have a helicopter. And then we also have the multicopter, which uses a vertical takeoff and a landing system. So VTOL means vertical takeoff and landing. And then it has a very simple structure, ease of use. So when you come to our research lab, we are able to build these drones. As at this year, by September, we're supposed to roll out a course to teach people how to build drones, to repair drones. But unfortunately, due to the virus, the program is still on hold. And once it is ready, the public will be made known. And then those who are interested in some specific career path will be coming to that career path. You can have a look. One of the main disadvantages.
Thank you very much for advertising. I'll send you your bill.
Oh, James, you made me laugh like a killer. So I'm writing it here, Pd1 Drone, CH3 drone, yeah. Yes, you can check these drones on the internet. You can also check Global Hawk. You can check Predator drone. Yes, James, you see, you've made people laugh like killers. Okay, now. So with the multicopter, one of the biggest disadvantages is the payload capacity. Unfortunately, due to the aerodynamics of multicopters, we are not able to lift a lot of payload, because once you lift heavy payloads, you tend to compromise on endurance. But the good thing is that technology is now changing. I know of a former Tesla battery engineer who have kind of disproved this disadvantage by building a drone that can now fly for more than 2 hours using the multi-copter system. So what he did was that he converted the whole drone into a battery. So it's more like a battery that is flying, just like what Tesla is. So Tesla is like a battery that is moving, you know. So I will find out the name of the drone and then I will share it in the chat session. Now, let's look at the system composition. Every drone has 3 major parts. And these parts include what we call a fuselage, let's say an airframe, the propulsion systems, the command and control systems. We are looking at a multi-copter system because this is a short training. We have a fixed wing system, but the foundation is here, that whenever you look at any drone, first try to find out what the airframe is, what the propulsion system is, and what the command and control system is. Now, the fuselage, the airframe is made up of 3 parts. So every drone has these particular parts, which is the fuselage, the arms, and then the landing gear. The fuselage is basically, if I compare the airframe, I can compare it to the human body. So the fuselage is more or less like my stomach, which contains all my intestine, my heart, or let's say all of that system. So with the drones, the fuselage contains or houses the battery, all the major electronic components that we are supposed to have the drone have some kind of power. So you have the autopilot that I showed you, the board being situated at this part of the drone. You also have the arms where we put the motors and then we run the cables with the other parts towards the fuselage. And these are the landing gears. So for example, if it is a fixed wing that needs a runway, the landing gear will have wheels. If it is a multi-copter system, it will have landing gears, which does not need wheels or does not need any runway. When we look at the propulsion system of a drone is made up of 4 parts. The first part is the battery system. So the battery provides a constant power source, which is a DC, to run the motor, or to, let's say, run the drone. The next part of the propulsion system is the propellers, which generate the thrust that we need in order to take off. And we have what we call electronic speed controller, which controls the amount of maneuverability with response to signals from the receiver to the drone. The motors are what the propellers are being attached on to generate the needed force in order to overcome gravity and take off. When you come to command and control, it is also made up of 6 parts, which is the RC transmitter. So this transmitter is with the pilot on the ground, sending instructions from the transmitter via wireless to the drone. And what you see here is basically the transmitter sending information to the receiver, which is this receiver, which is this receiver here. So the receiver is always on board the drone. You have this also on board the drone. You have the propeller also on board the drone. And you have the GPS, which acts as a navigation hardware, providing the location information to the drone, as well as the pilot on the ground. So this is also on board the drone. Now, in my earlier screen that I shared, this is the autopilot system that offers the intelligence, which I showed you via my camera. So this acts as in computer terms, we will say the motherboard. And this sits exactly in the middle here, where the GPS is connected to it. Sorry, the receiver is connected to it. The GPS is connected to it. The electronic speed controller is also connected to it. And all these parts are on the drone. So once we have the drone in this direction, the question now we need to ask ourselves is that how do we communicate with the drone once the drone is airborne or once the drone is in the air? We use what we call ground control station. And ground control station is made up of 2 parts. We have the telemetry radio, which is this radio device, and we have the ground control station here. Now, the ground control station is a piece of software that runs on any normal laptop with a very good speed. And the radio telemetry device is a hardware that has the receiver on the drone and the transmitter on the ground. So what it does is that it sends the receiver, which is on board the drone, sends real-time information in terms of the altitude of the drone, the speed of the drone, the position of the drone, directly to the radio telemetry device. And the radio telemetry device is connected to our PC via a USB, and we get to see it on our ground control station. The interesting thing about the autopilot system is that it has an accelerometer, a barometer, it has an IMU, and it also supports what we call real-time communication. So for example, you can attach something like a Raspberry Pi to this autopilot system, and you can connect it to our telecommunication network infrastructure. So when you look at a company like Zipline's drones uses SIM card, which piggybacks on our telecommunication infrastructure to get to know the position of the drone. Primarily, we fly drone based on two configurations. That is what we call beyond visual line of sight and visual line of sight. So with visual line of sight, what it means is that you the pilot, your human eye can see where the drone is. But with beyond visual line of sight, the human eye cannot see where the drone is, which means that it flies beyond your visual range. And with that, you still need the position of the drone. You still need information of the position of the drone. So, yes. With regards to the RC transmitter, Franklin, answering your question, the transmitter uses the 2.4 gigahertz extended frequency range, which can cover up to normally what is on the market. It can do between, if you look at the DJI product, you can do between 1 to 7 kilometers. And the latest ones, you can do between 1 to 12 kilometers. Most of these transmitters have two modes. One is the RC mode or the Wi-Fi mode. Wi-Fi modes, you are mostly limited to 100 meters. But if it is a Wi-Fi extended, then you are looking at this particular one. So DJI drones are using the 2.4 gigahertz. And these are what we call the extended modes. The distance that the manufacturer gives you, it's sometimes terrain dependent. So you may fly in an open space like Bondasi, and you can get exact 12 kilometers where there's no interference. But if you bring it to an urban environment where you have a lot of high-rise building, you have a lot of interference, you may not necessarily be able to achieve that 12 kilometers. So bear that in mind due to what we call channel noise. There's a lot of noise that tends to affect the free space communication between the transmitter and the receiver. And this noise could be either destructive or constructive. Yes, what happens if the drone flies out of range? So in most of our systems configuration with the autopilot system, we do configure what we call fail-safe systems. So with the fail-safe systems, what we do is that when we are programming the drone, we program the drone in such a way that if the transmitter is not able to constantly keep communication with the receiver for a certain period of time, the drone should return to home. And that is one of the features that we do a lot. It's called return to launch or return to home feature. So a lot of drones have this functionality. So constructive noise could also extend the range or sometimes boost the range of the drone. But destructive noise limits the range of the drone. Yes, so that is the difference between the constructive and destructive noise. So noise may not necessarily mean something bad, but we have some type of noise that really also extends the range of the drone, or some that the. Now I will share my screen and show you a typical ground control station that I use to program the drone. So let me stop this screen and then show you the mission planner software. So, just a second. Unfortunately, I'm very new to your Microsoft system. I'm mostly used to Zoom, so forgive me for my. Okay, so let me share my screen and launch mission planner. Yeah. So can you all see